Okay, what's going on, folks? Today we're going to be learning about work. Our goal for today is that you can relate the work done on an object to the force and change in position of the object. Um, and then I want you to be able to use that relationship to solve problems involving work. You're going to take notes on how to calculate the work done on an object, and then you're going to practice calculating the work done on an object. So what is work? Work is the energy transferred to an object via the application of a force in a certain direction. So if you apply a force to an object and move it in a direction, and as long as the force is in the same direction as the way the object is moving, you will be giving that object a certain amount of energy. The work done on an object is determined by the size of the force and how far the object moves. So the bigger the force, the more work you're doing on an object, and the more the object moves, the more work you're doing on that object. The formula for calculating the work done on an object can be found below. So that's work equals force times change in position, or W equals F times delta X. So W in this stands for work, F stands for the applied force, and delta X is the change in position. Okay, so what are our variables in this situation? We've got work, that has the symbol W. Work is a type of energy, so it's measured in joules, and the abbreviation for joules is J. The next variable is force. Force has symbol F. Remember that the unit for force is newtons in science, and it's abbreviated in N. And then last up is change in position. We give that symbol delta X, so a triangle and then an X. That has the unit meters and the abbreviation M. Okay, so recall that Newton's second law states that the net force acting on an object can be calculated by multiplying the mass of an object by its acceleration. And so that equation is F equals F equals M times A, where F is the force measured in newtons, M is the mass of the object measured in kilograms, A is the acceleration measured in meters per second per second. Okay, let's go through a couple example problems. Doreen is pulling a wagon with her little sister in it. Doreen pulls the wagon with 310 newtons of force. Doreen pulls the wagon 17 meters. How much work will she do? So we're looking for work. We know the force, that's 310 newtons of force. We know the change in position, that's 17 meters. So then we'll write our formula. Work equals F times delta X. Work equals 310 times 17. Work 310 times 17 is 5,270. And then work is measured in joules, so 5,270 joules. Should be pretty straightforward. So Alexandra is pushing a 10 kilogram boulder which accelerates at 0.1 meters per second per second. The boulder moves 8 meters. How much work did Alexandra do? So we're looking for how much work she did. Force that can be calculated from 10 kilograms times 0.1 meters per second per second. All right, so that's just F equals M times A, so we need to multiply these two values together to get the force. Taking my mass times my acceleration, that should get me to 1 Newton. Okay, delta X, change in position, that's going to be 8 meters. Then I'm going to use my formula. Work equals force times change in position. So work equals 1 times 8. Our work is going to equal 8 joules. So the difference with this problem is we actually had to calculate the force. We did that by taking force times, by taking the acceleration times the mass. Okay, so then one more example. This one's going to be kind of like example 2. Karina is lifting weights at the gym. She lifts a 25 kilogram barbell over her head to a height of 2 meters off of the ground. How much work did Karina do? So again, we're looking for work. For the force, we're going to take 25 kilograms and then we're going to multiply it times 9.8 meters per second per second. Now, why are we multiplying it times that value? Because that is the acceleration due to gravity. She's lifting it upwards. Whenever you're lifting something upwards, you're fighting against gravity to lift it up. So the work will be determined by the mass times the acceleration due to gravity, which is 9.8. So we should get 24.5 newtons. For delta x, that's the change in position. She lifted it 2 meters. Right? So that's going to go in like that. And so then weight is going to equal force times delta x. Weight is going to equal 245 times 2. Weight's going to equal 490 joules. So as we're looking at examples 2 and 3, for examples 2 and 3, we both had to calculate the force. In example 2, I gave you the acceleration. In example 3, I didn't give you the acceleration, but because she was lifting it upwards, her force is 245 newtons. Okay. And so then go ahead and try the practice problems. They relate, each practice problem relates to one of the examples. So if you're not sure, try to figure out which example it correlates to. And then we'll go over this next week.